Let's look at some examples of adding and subtracting polynomials. Here we have 5p squared minus 3 in brackets plus 2p squared minus 3p cubed in brackets once again. So the first thing we need to do is to get rid of the brackets. So because there's a positive, there's a plus in front of this expression even though we have not written it, then we simply get rid of the brackets. 5p squared, and we bring down the terms minus 3, and also we need to get rid of the brackets of this expression. There's a plus in front, so we don't need to worry about it, so we simply get rid of these brackets and we bring down the expression, so it becomes plus 2p squared minus 3p cubed. Now the next thing that we need to do is to collect like terms. Now like terms have the same variable and the same exponent. So let's begin with this one, 5p squared. Are there any like terms to this one? Yes, 2p squared, because it has the same variable and the same exponent. So we just simply bring it and put it together, right? Let's group like terms. So plus 2p squared. Any more like terms to these two? No. Next, minus 3. Any like terms to minus 3? No. Okay, so we simply write it down. We still need to bring it. And we already took care of this expression. Any like terms to minus 3p cubed? No. It's the last term, so we simply bring it down. Okay. Now we can only add and subtract like terms. So 5p squared plus 2p squared will give us 7p squared, and we write minus 3 and minus 3p cubed. Okay, so that's one example. Let's look at another example here, and let's look at 5a in brackets plus 4 minus 5a plus 3. Okay, so it's very similar to the previous example, but in this case we have a minus in between the expressions. So there's something that we need to do in order to take care of these types of problems. So I'm just going to move this up so you can see. So we have 5a plus 4 minus 5a plus 3, and so the first thing we need to do is let's get rid of the brackets. So now we have well, there's a positive, there's a plus in front of this expression, so we simply bring down the terms. 5a plus 4. Now there's a minus in front of this expression, so whenever there's a minus, what we do is we switch the signs. We switch the signs of each of these terms, right? So if there's a minus, we switch the sign of each of the terms within the parentheses, within the brackets. So 5a, what's the sign of 5a? The 5a is a positive sign, so it will be negative when we bring it down. So negative 5a, and plus 3 becomes minus 3 when we bring it down. The next thing we do is we collect like terms. So 5a, any like terms to 5a? Yes, negative 5a, right? Same variable, same exponents. The exponent here is 1 even though it's not written. And now let's bring down the plus 4. Any like terms to plus 4? Yes, the minus 3. Alright, now we can add and subtract like terms. So 5a minus 5a gives us 0. We don't need to write it, but I'll write it now for explanation's sake. And then plus 4 minus 3 becomes 1, positive 1. Alright, so essentially this is equal to 1. Okay, let's look at another example. And in this case we're going to have negative 2a plus 7 plus 3a minus 5. Alright, let's move up a little bit more, and hopefully I can fit this on the space that I have left. But yes, so by now you should be getting the used to the pattern here. Now we need to get rid of the brackets, but in this expression 2a plus 7 we have a negative sign in front. So if there's a negative in front of the expression, each of the terms switches signs. So the 2a, the positive 2a becomes negative 2a plus 7 becomes minus 7. So we got rid of those brackets. There's a plus in front of this, so we simply bring down the terms. And then, once again, we collect like terms. So negative 2a. Any like terms to negative 2a? Yes, we have the plus 3a. Minus 7. Any like terms to that one? Minus 5. And let's simplify this. So minus 2a plus 3a becomes positive 1a. Minus 7 minus 5 becomes minus 12. So that's our answer. Finally, let's look at one more example. And I suggest that whenever you try these examples, you can always pause the video and perhaps try it yourselves and then compare your answers to the video. So our last example is 3 minus 6n to the power of 5 minus 8n to the power of 4 minus 6n to the power of 4 minus 3n minus 8n to the power of 5. So yes, this is a little more challenging. As I said again, you can pause the video, try it yourselves, and then you can compare the answer. Alright, so same thing as before. Let me use green now. Let's get rid of the brackets. Right? There's a positive, there's a plus in front of this expression, so we don't need to worry about it. We simply bring down the terms. So 3 minus 6n to the power of 5 minus 8n to the power of 4. Now there's a minus in front of this expression, so we know that each of these terms will switch signs. So this minus 6n to the power of 4 becomes positive. So positive 6n to the power of 4. Minus and minus becomes positive. And here this becomes a positive as well. Right? Another way of looking at this is pretending that there was a 1 here, which in fact that's exactly what is happening, and then we use the distributive law. But more about that on future videos. If you want to keep it simple, right, if there's no number there, you assume there's a 1, and anyways, you do these examples, okay? Now let's collect like terms. Any like terms to the 3? No. So we simply bring it down. Any like terms to negative 6n to the power of 5? Yes, that would be this term right here, 8n to the power of 5. Any like terms to minus 8n to the power of 4? Yes, the positive 6n to the power of 4. And lastly, we need to take care of the positive 3n. No like terms to this one. Now let's simplify this expression. So we have negative we have the 3 here, negative 6,5n plus 8n to the power of 5. This becomes positive 2n to the power of 5. Now remember, once again, you can only add or subtract like terms, and these two become negative 2n to the power of 4 plus 3n, and that's our answer. And let's simply write it with the expression that has the highest exponent first going down. So 3n plus 3. Okay, so these two are the same. If you leave that as your answer, you will get full marks. Same thing for that one. It just looks neater with the expression with the highest exponent appearing first. Any questions, let me know, and don't forget to subscribe.